One second. Trying to get this going. Yeah, yes. We're live on YouTube as well. Let's go. So today we're gonna talk about something very important. When I used to take algebra and stuff, and that was kind of tricky for me. It's called, it's matrix operations. We're gonna do a little bit. We're gonna start with vector operations, and then we're gonna do a matrix operation, especially multiplication, and then after that, we're gonna move on to other stuff. I have not text anyone saying that I'm live. Let me try to go ahead and do that. This is not. I'm not doing this the way that I normally do it. Hey, what's going on? Who do I see here on YouTube? Let me try to text people saying that I'm live. Live, new, live. We are live on TikTok and YouTube. Hey, YouTube. All right, if you part of my contact, you're probably gonna get this text. I sent it. All right, um, yes, today we're gonna be talking about matrix multiplication. And hey, Jess, Lala.02, Jess.G24. What's going on? What's up? So we're doing matrix operations today, and then answer any questions that you guys have, of course. That's why I'm here. Let's see who's here. Who else is here? Hey, Jess, what's going on? Let's see who else is joining. Abby, Nicole _2. What's up? Yo, it's Leela. What's going on? Sam Jacobs 55. Sam, didn't you have a test or something last time? Hey, what's up? Hey, Leela. And I'm trying to find a way to pronounce your name. What's going on? What's up? And everyone on YouTube too. What's going on? I'm trying to see how you guys coming in. Turk, something adventures. What's up? Those names are funny. I be trying to see where to take the break. Hi, 39. I haven't seen you here in a while. What's up? What's up? Rebooting. What's going on? Rebooting. What's going on? Brand Wonder, what's up? April M20 was good. Sam Jacob 55. Welcome back. Let's see who else is on YouTube. All right, so we're gonna go quick, and then I'll answer questions from you. So we're gonna do matrix operation, and then we're gonna do other things. Let me put this. Let me flip this around, like we always do. Let's set this down. If you guys can see the board, let me know. If you have trouble, let me know as well. We're gonna go real quick. Actually, let me wipe this. Sorry, everyone on TikTok. I had to wipe this, make it look a little bit better for you. All right, cool. So, all right, y'all. Let's go. So, if you take in algebra 2, I think they start doing this with you. They start doing matrix operation and multiplication. So let's go. Let's start simple. Let's start with a vector. So let's say we have so first I got to tell you about dimensions. So dimensions. So if you think about something like this that has 1, if you're thinking about, let's say there is a 3 right here. Let's say, let me start this off right. So let's say there's a 3 right here, and this is all you have. So you would consider that, a 1 by 1 vector in terms of dimension. If you can say, just 1 by 1. So one row going this way, one column going that way. So that's all. Now, if we add another number to this 3, let's say you put -5 here, that's how many, what's the dimension of this vector, of this, or this matrix, if you want to call it that? So what's the dimension of this? So we say the row first, and then we say the column. So how many rows? 1, 2 rows. And then how many columns? 1 column. And that's all you do for this one. So 1 column, and then 2 rows. 2 rows, 1, 2, 1 for this one that has the 3 on it, and a row that has the 5 on it. But columns is one, it's only 1 column. Now, let's add some more stuff. So let's say I erase this. I erase this, and I start adding more numbers to it. Let's say I add number 8 and then a number 7. Now, what's the dimension of this matrix that we have here? Now, you can no longer call this a vector. This is a matrix. So what's the dimension of this? Who can tell me what's the dimension of this matrix that we have here? Let me see who got me. All right, let's see. The dimension of this matrix on the board. Come on, let's see who got me. Come on, guys. If you don't say it, I'll say it before you. But if you do, I'll give you a shout out. What's the dimension of the matrix on the board? It's a 2 by 2. Ashy sneeze. Ashy knees. Good job. Yes, that was good. Say 48. Phoenix something. That wasn't a 48. All right, so they call that a 2 by 2 matrix. A 2 by 2 matrix, and it's easy stuff. 2 rows. So you say the row first. 2 rows. 1 row, horizontal row. 2 rows. One going this way, another one going this way. So 2 rows, and how many columns? 2 columns. One going here, one going here. You might think that, okay, is it always going to be a square? Not really. Let me trick you for a little bit. So remember, when we say the dimension, we say how many rows, and then after that, we say how many columns is in it. So let's go in this one. Let's go find something else. So let's go find another matrix that 1, 6, 5, 2, 3, 7. All right, let's say we had a matrix like this. What's the dimension of this matrix? Whoever say it, I'm gonna give you a shout out. If you don't, I'll say it before you. All right, let's see. What's the dimension of this matrix here? This is the whole thing we're talking about. So remember, when we're reading it, we say how many rows it has, and then we say how many columns. So it's how many rows times how many columns. So let me see what you guys have. What's the dimension of this? 3 by 2. Courtney and 1 Cole. 3 by 2. That's right. So that's a 3 by 2. Who else said it? Let's see. You got it right the first time. It's a 3 by 2, not a 2 by 3. Jess G24. That's what's up. I'm so confused. Sammy was here. To Phoenix, as you got it the other round. Hi, 39. Confused. Okay. All right. Let me explain. Okay. So let me stop and explain. So what we're doing here, we're going through matrices. Before I show you how to do operations on them, Soda, what's up? 12, 6. We were just doing the dimension. So before I show you how to do operation on those matrices, I wanted to show you how to, how to read the rows and columns. Because the reason why I want to show you that is because, unlike when you have regular numbers like 5 multiplied by 7, you multiply them by 5 by 7. When you're doing matrices, it's not like that. There's rules to follow based on the rows in the columns of matrices. So what I'm showing you right now is how to read those. How many rows, how many columns. Those are the dimension of the matrix. So in here, this matrix has 3 rows and 2 columns. So the rows are the stuff going. If you're going this way, how many times can you? I mean, how many of these you see? 1 row, 2 row, 3 rows. Columns. If you're going down, how many columns? one column that has a 1, 6, and 5, and another column that has a 2, 3, and 7. So that makes it, so the way you read it is the rows first, 3 rows we found, and then we also found 2 columns. So it's a 3 by 2 matrix. And that's all we're doing in this one. And then after that, that will allow us to do additions and multiplication and all that stuff on those matrices. Now, let's go ahead and do and give you guys another example. I know you're probably gonna get this. So let me do it fast. Let's see who's gonna do this first. All right, so let's say I have 2, 6, 7, 3, 5, 1, -6, -4. So what's the dimension of this matrix? Remember, we're reading the rows, and then after that, we're going to read the column. So it's row first, column second. Dark matter, what's going on? Yes, I remember you, of course. Hey, what's good, man? Hey, say 2 rows, 4 columns, 2 by 4. That's right, Courtney. Ashley, need us, right? Sammy was here. That's right. 2 by 5, 4 by 5. How did you get 4 by 5? Phoenix Banks 1. How did you get 4 by 5? I got it now. Thank you. No problem, Sammy. That's the whole goal. Make sure you get it. Phoenix Bank. I don't know how you got 4 by 5. Let me know how you got 4 by 5. Jess G24. You're starting to understand. 2 rows and 4 columns. That's what's up. So yeah, 2 rows. 1 row going this way. That row has the 2, the 6, the 7, and the 3 on it. That row going that that second row has the 5, the 1, the 6, and the 4, and then -6 and -4. So how many columns do we have for this matrix? 1 column going this way. This column has the 2 and the 5 on it. Another column going this way that has the 1, the 6, and the 1. A third column that has the 7 and the -6. A fourth column that has the 3 and the -4. So that's how many rows, how many columns. We found how many rows, the ones on black. 4. Actually, if you do this, you'll be able to tell how many rows for a row. I mean, 2 rows, not 4, 2 rows. 2 rows, the ones in black. And how many columns in green? 1, 2, 3, 4 columns. So this matrix is a 2 by 4 matrix. Now, good job, Dark Matter, 2 by 4. Colton, 10, what's going on? Scarlet, thank you. Dark Matter, what's up? All right, cool. Now that's it. All right. So now we know about the row, how to read the matrices and say, hey, this is the dimension, how many rows and how many columns. So now, just like every other things that we learn about, there's going to be additions and subtractions and multiplications and divisions in those things. So today I'm going to show you how to add them. It's also almost similar to subtracting them. I'll show you how to do that. And then multiplication. And I'll show you some other stuff that they talk about when you have matrices, like something called determinant of a matrix and something called, the transpose of a matrix. So you'll see those Melina, thanks. You should be a math teacher. Thank you. All right, so you'll see those later on. So let me see. Let's start with this one. So let's say we have these 2 matrices right here. So let's say we call this one matrix A, and we call this one matrix B. So let's say we want to know. Before I go in there, I keep forgetting. All right, let's start slow. So let's say we have 2 vectors. So don't worry about what I was saying earlier. Let's say we have a vector here of 0, -1, and then let's call this vector A, and then we have another vector B. That has, that is 3 and -3 and 4. So how do we add A and B? Now, before Who can tell me what the dimension of A and B are? They both have the same dimension. What's the dimension of A and what's the dimension of B? The same dimension for the one. Just like we were saying in the matrices, what's the dimension of this vector? Let's see. Let's see. 2 by 1. Yes, Sammy was here. Remember, we're gonna say 2 by 1. Sammy was here. Good job. Now you got it the second time. Yes, that's right. Those are 2 by 1s, matrices or vectors. So 2 by 1s. 1, 2 rows. How many columns? 1. All right, cool. So now we got that out of the way. So the only way you can add these 2 vectors if they have the same dimensions. So with that being said, if this one was a 3 by 1 and that was a 2 by 1, we couldn't do nothing about them. So the way you add them is, as you would think about let's say you wanted A plus B. So what you would do is you'll put the A right here, 0, -1, plus the B, -3, 4. And this is not rocket science. You can see. So the A by the B. Now, another thing that I want to tell you, when you're adding those, you're going to add corresponding, elements, places. So this is in the first row and first column. So this one right here, the position of this is in the first row and also the first column. So we're going to find something else that's in the first row and first column. This one is in first row, first column. You cannot add the 0 and the 4. So when you add them, that's why they have to be the same dimension. So let's say you had a matrix that was, a vector that was 1, 2, 5, and another one that was 1, -6. You cannot add those. You cannot add them. Because this one has something to match it. This has something to match it, but this doesn't have anything to match it. So you got, when you're thinking about adding them, the best thing to think about is, what's the position of this? This 0 right here, it's in the first row and first column. I'm going to find something that's also in the first row and first column, and that's the -3. This -1 right here, it's in the second row. So the second row, this is the first row. This is the second row. First row, this is the second row, and this is the first column, and I'll put these in green so you can understand how to add them. First column, second column. Actually, why am I saying second column? So this is the first column for matrix A, and this is the first column for B. First column for B. First column for B. All right, cool. So 0 is in the first row, first column. I'm going to find something in the first row, first column too. So that would give me 0 -3. 0 -3. Now I'm going second row, first column. Second row, first column. So that gives me -1 plus 4. And that's the only way I can add those. And that's the only way I can add those. So that would give me what? What does that give for this matrix? 0 -3 is -3. -1 plus 4 is 3. -3, 3. Let me see if anybody said it. Let's see. Let's see. All right, cool. Cat, Kono, if you're taking it this Saturday, it's probably won't be much I can do. If you go on the site, thejackstutor.com, you will see options for help. But if you're taking it this Saturday, there's not much I will be able to do. because I'll be honest with you, there's no way I can raise your score from from a 200 to an 800 in a couple of days. It's just not possible unless you already know what's up and you just didn't have how about whenever you pass geometry, that's what's up. L's Adventure 101, that's what's up. Good job. I would say if you taking it the next time and you want to start working with me, go on the jaxtutor.com and you will be able to schedule time to work with me personally. For as far as Saturday is concerned, there's not really much I can do about that. So I would have to sit down with you and make a plan for you to pass instead of just giving you pointers, because it's a whole test. It's not like you have one problem you have something with. If you like you saying, if you're having trouble scoring higher score, it's probably easier for me to just to start over with you, because you're saying you've been doing tutoring for a long time and you haven't been able to score higher. So if you go on this website, the jaxtutor.com, if you go on this website, of course, www, if you want to put that. So if you go on this site, and you can actually schedule a time to work with me personally. So for Saturday, it won't. There's no way I can. I don't know. Like if you haven't had a chance, if you haven't been able to increase your score, there's no way I can guarantee you, hey, you're gonna increase your score in today's Tuesday. So it probably won't be happening. I'll be honest with you. Now, the next time you want to take it, if you want to study with me, I have a whole plan layout for kids who study with me, and then I go from wherever you at to have them where you want to go. So I wish you luck this Saturday, and if you want to work with me, you know how to find me. All right, cool. So let's get back to what we're doing. So, okay, so I get -3 and 3. So that's what's really important in matrices. Let me do another one that's a little bit more fun, and then after that, we're going to move to probably multiplication. So it's something that's a little bit more fun. And you guys, if you know what's this going to be, let's take these two matrices, 1, -5, and then 3, 0. And then I want to add that. Let's say this is called the matrix A, and then this is called the matrix B. I want to add that to a matrix that's what? -4, 2, 0, 1. So now, how do we add those? Remember, the same thing we've been saying all night is think about rows and columns. We're going to add things that are in the same position. If they're not, you cannot touch them. There's no way you can add this one to this one. They won't even see each other. Think about them as in different locations. So this number 1 right here is in the first row, first column. How do I know this? 1, 2. 1. Oh, let me use a different color actually. 1, 2. So 2 rows, 2 columns, but each one of them has a different position. So I'm going to ask you guys, where is 3? Who can tell me what position is 3? 3 is 3 in this matrix. What position is this? And I'll in the meantime, I'll draw the other ones. So this guy right here is in there. 2 rows. Let me do the rows first so I don't confuse you. 2 rows, 1 row, 2 row, and then 2 columns. 1 column, and then the second column here. So now, this is the first row. Let's see, first row, second row, and then this is the first column, second column, and this is all for matrix A. Now you I asked you guys, what position is 3 in? What position is this 3 in? And what position it is? So, all right, let's do this one. So this is the first row. First row for matrix B. Second row for matrix B. And then first column, second column for matrix B. Now, let me see if you guys have the answer. What position is 3 on? 3 is in the first row. Now you got to say the row and the column. So let's see. Sammy was here, first row. Okay, so he said first. Okay, first row, second column. First row, second column. First row, second column. So first row, second column. That's what's up. Yeah, I get what you were saying, Sammy. So first row, second column. Good. Now, if what am I gonna add 3 to? Knowing that it's in the first row, second column, what number I'm gonna add it to? Tell me. What number in this matrix I'm gonna add 3 to? So in this matrix, there's a number in this matrix that I'm gonna add 3 to it without knowing anything else. What number I'm gonna add 3 to? Which one of those I'm gonna add 3 to? Is it gonna be added to this, to this, to this, or to this? So tell me what number I'm gonna add 3 to when I'm doing this. All right, let's see. 2 in matrix B. That's what's up, JSG24. That's what's up. Yes, that's good. 2. Yeah, Sammy was here. That's what's up. Yeah. So I'm going to add it to 2. Okay, so let's start. I'm going to leave this here for a little bit so you always have him as reference. So first row, first column. 1 plus -4. And then notice that's going to be in first row, first column. So I added these 2, but I also put them in first row, first column. If I added them and I put them right here, no, that's not good. First row, second column, 3 plus 2. I added 3 and 2. I'm going to put it in the first row, second column for this matrix. This is going to be a matrix by itself. Second row, first column, second row, first column, -5 plus 0, -5 plus 0. Second row, second column, 0. And I'm going to add that to 1, 0 plus 1. Now, okay, so I think this is it. Now, I can erase this maybe. All right, so let me make this look like the one below it. So this guy right here, 1 minus 4 is -3. 0 minus -5 plus 0 is -5. 2 plus 3 is 5. 1 plus 0 is 1. So when I add those 2 matrices, 1 minus 3, 5, -5, and 1. And that's the resulting matrix. Notice it's the same dimension as this. 2 by 2 matrix, and that's the dimension of it. Now, I want to show you 2 things, and then we're going to move to multiplication. All right, so first thing I want to show you is, just like when you have vectors and also matrices, you can multiply them by a number. So it goes kind of like the way you would think of it. If I have the number 3, I want to multiply by the matrix A. So it's going to be 3 times the matrix A. What's the matrix A? 1, -5, 3, 0. 1, -3, 5, 3, 0. So what I'm going to do here, that 3, because it's a constant, it's like a scale. So it's going to be multiplied by each one of those. It multiplied by this, multiplied by this, you multiply it by this, you multiply it by this. You're going to result in a matrix. You're going to give you a matrix that's 3 times 1 is 3. Who can tell me what's going to be in here? I'm going to do the other one in here. In the second row, first column, what's going to be here? So 3 times 3 is 9. 3 times 0 is 0. So what's going to be here in a little spot that I live here? That's not a 0. I just leave a spot here for you to tell me what's going to be in the second row, first column. What number is going to be there? Let's see. Who got me here? All right, so let me see who got me. Negative 15, negative 15. No, this is not calculus. June, 12. This is algebra 2. Negative 15. That's what's up. I don't know if they actually do this in calculus, but this is mostly learn this in algebra 2. Or yeah, I think algebra 2 they will teach you this. Okay, so yeah, negative 15, negative 3 times 5, negative 15. 3 times negative 5, negative 15. Yes. So now also the same way we multiply 3 here, if we had a negative 1, we can do that. We can multiply that negative 1 by here. Let me erase this. So if I multiply negative 1 by here, who can tell me what's going to be here in this column, in this position? So the position is first row, second column. I'm going to leave it empty. Who can tell me if I multiply negative 1 by here, what's going to be in this position? So negative 1 times 1 is negative 1. Negative 1 times 5 is 5. Negative 1 times 0 is 0. What's going to be here? Let me see who got me. Let's see. Oops. I did something crazy. Wow. I don't know what's going on with this. 1 second, guys. Oops. Let's see if I can find my messages. Uh-oh. Hold on. I don't know why this keep having me type. All right, let me just write something on there so it can. All right, cool. Who can tell me what's gonna be in here? Negative 3, negative 3. Maya underscore JS. Negative 3, Noel, 32, 16, 0. Yeah, it looks like everyone's saying negative 3. Let me see what we have. So we multiply negative 1 times 3. That gives you negative 3. Yeah, that's right. Negative 3, that's what's going to be here. All right, cool. Now, it looks like you guys got it. Now, one thing, when you say you can add stuff, that means you can also subtract stuff. You can say A, matrix A, minus matrix B. So the easiest way to do that is, so what you would do is you would take the matrix A and then you would take the negative of matrix B. So you see how we multiply this by negative 1, multiply this by negative 1, and then you add them together. So it's kind of like A minus B is equal to A, matrix A minus matrix B is equal to matrix A plus negative 1 times B. So because you can do it. Of course, you can do it by hand. You can say, hey, 1 minus 4, that would give you 5. 3 minus 2. You can do it that way too. But sometimes people find it easier to do it this way. So if you were doing A minus B, you'd do 1 minus 4, the same way we've been doing it. 3 minus 2, negative 5 minus 0, 0 minus 1, and then you would get those 4 entries. Now, all right, let's do some more fun stuff. Let's do multiplication. Okay. Now, remember when we were adding and taking the difference from one matrix to another between two matrices. Remember when we were doing that, we say it needs to be the same row, the same column. Now, the same number of row and the same number of columns in the first and second matrix, they need to be the same. So a 2 by 2 plus a 2 by 2, a 2 by 1 plus a 2 by 1, a 2 by 2 minus a 2 by 2, 2 by 1 minus a 2 by 1. Now, when you're doing multiplication, it's you have a little bit more leeway. You have a little bit more freedom, but you got to know what you're doing. So in order for you to add two matrices, let's say I have a matrix here, A, B, C, D. I won't use letters so you don't confuse. E, F, G, H, I, J. When I'm doing exercises, I won't actually use letters. So in order for me to add these two matrices, what needs to multiply these two matrices, what needs to happen is and then I'll show you how to get this easier. The number of column in the first matrix needs to be equal to the number of row in the second matrix. So that means this guy is a 2 by 2. And then that other guy is, what's the dimension of this matrix? I won't tell y'all. Let me see. What's the dimension of this matrix? So this matrix right here, how many rows, how many columns? Let's see. Thank you, ARJ Master 101. Thank you. I appreciate you. I'm glad that you like the videos. All right, what's the dimension of this matrix? So somebody says the 3 by 2, Jess G24, you are killing. That's what's up. Yeah, it's a 3 by 2. KD.BB math still hard. I understand. I feel the same way sometimes. So it's a 3 by 2. Now, remember what I told you? The number of column in the first matrix, that's the only way you can do the multiplication. The number of column in the first matrix needs to be equal to the number of row in the second matrix. So what that means is these two numbers need to be equal to each other. If you don't remember, hey, number of column in the first, if you don't remember that, which is hard, because you have to think about it, just write the dimension of these two matrices and say these two numbers are going to be equal to each other. Now, in this case, we cannot multiply these two. Now, if, on the other hand, if I had a matrix that looks like this, and you can probably already tell what I'm about to do, M, P, Q, R, L, V, T, Z. If I had two matrices that looks like this, one looked like that and the other one looked like this, what's the dimension of the second matrix, by the way? Who can tell me what the dimension of the second matrix is? Let's see. Let's see who got me. Jess. Are you still here? Sammy. You guys were intern earlier. Oh, Lord. I don't know why this keep having me write stuff. You can see the board. Wow, that's interesting. Is anyone having trouble seeing the board too? Let's see. Anyone else having trouble seeing the board? I can't see the board. Jess G20. Oh, is it? Okay. Jess, do you have trouble seeing blue? Because that's written in blue. If you have trouble seeing colors, let me know. Yeah, so what's the dimension of this matrix? So the second matrix just is the one that has the M, P, Q on it. Let me know if you're able to see the board now better. All right, what's the dimension of the second matrix in blue? Nobody got me? I'll just tell you guys. All right. You probably know already. It's taking you a little bit to answer. So how many rows I have in this matrix? 2 rows. How many columns? 1 here, 2, 3, and 4. So that's a 2-row and 4 column. So when you're doing multiplication of matrices, what you want to make sure is these two numbers match. And now, and what's going to happen is they gonna think about, okay, all I need is those two numbers to match, and in the matrix that's going to form is a matrix of this dimension, 2 by 4. Let me say this again. So let's say I have a matrix that's 3 by 1, and then I have another matrix. I'm multiplying that by another matrix that is 1 by 5. These two numbers match. That means you can multiply the matrices. I can erase them because they match. And then the matrix that's going to form is a matrix of 3 by 5. And it's crazy for you to think that, but that's true. If you have a matrix that's say 1, 2, 5, you multiply it by another matrix that's what? Multiply that by a matrix that what? 1, 3, 7, 2, 6. So that's a 3-row and 1 column by a 1 row and 5 column. That's going to give you a matrix that's 3 by 5. So that's going to expand to something that looks like that. 3 rows and then 5 columns. So you have this little thing multiplied by this little thing. It's going to give you something that like that. So the way I always remember this is if I have 2 matrices, 4 by 2, for example, by another one, 2 by 7, what I need is the numbers in the middle to match. As soon as they match, I can erase them. I'm going to end up with a matrix that's 4 by 7. And that's all you need to remember. If you try to remember, the first row of the second matrix, like sometimes it could take you a long time to remember that. But the way I remember it, I said, hey, I have one matrix that's 1 by 3 times another, multiplied by another matrix that's 3 by 2. What am I gonna? So okay, first thing I ask myself, can I multiply them first? The numbers in the middle need to match. Okay, they match, and I just erase them. And then you're gonna end up with a matrix that's 1 by 2. All right, let's do some example. So does that make sense? Is that clear for you guys? Is this clear for you? When you multiply them, what's the matrix you're gonna end up with? What is it gonna be? Is that clear? Let's see. If that makes sense to you guys. Okay. All right, Jess. Thank you. I appreciate you answering. Yeah. Okay. I'm glad you can see the board now. All right. Cool. Does that make sense? Yes, I understand. There you go. All right, Jess. That's what's up. Now, let's do some example. Fun stuff. Cool. So I'm gonna go with these two. I already have them here. 2 by 2 matrices. So the first one is 1, and then go to 5. And then who can tell me what's the dimension of the matrix that I'm going to end up with after I multiply these two? And I'll give you time to answer while I'm writing this. -4, 2, 0, and 1. After I multiply this two, who can tell me what's the dimension of the matrix that I'm going to end up with? So the first matrix is a 2 by 2. The second matrix, I don't know why. This light is messing the whole show up. It's not cooperating on YouTube. Let's see. I guess I need to turn it off. Let me see how it looks if I turn this off. All right. Ooh, that's a completely different view. Let's see how it looks on this. It's not that bad, actually. All right, good. We'll take the slide off. All right, cool. So who can tell me what's the dimension of the resultant matrix of this? When you multiply these two matrices, what's the dimension of the matrix going to be? So let me see who got me. 2 by 2, Jess, that's what's up. 2 by 2. Yeah, whoever answered 2 by 2, correct. There we go, Jess, that's what's up. Now, how do we multiply? So remember, it's easy, but you got to remember. So what we're going to do is we're going to take, so it's row times columns. So the matrix that I'm going to end up with is a 2 by 2 matrix. It's going to have 2 rows, 2 columns. So what is going to be here is the product of so this position is first row, first column. Remember, row 1, row 2, column 1, column 2. Now, this position is first row, first column. In order for me to find this matrix, the resulting matrix, whatever is going to be here, the entry on the first row and first column, I'm going to take the first row of the first matrix, multiply by the first column of the second matrix. And I'm going to do something called like the dot product. And I'll show you what this is. So I'm going to take, what's going to be here, it's going to be in a position first row, first column. For me to find that, I need the first row of the first matrix times the first column of the first matrix, of the second matrix. So first row of the first matrix times the second column of the second matrix. So what's the first row of the first matrix? First row times the first column. I need a different color. Where's my green? There you go. Times the first column. And we're going to do what we'll call a dot product. So dot product basically means we multiply this one by this one, and this one by that one. So what's going to end up here is 1 times -4 plus 3 times 0. 3 times 0. And that's what's going to be in the first row, first column. Now, let me see who's smart. So in here, this is in a position, as you already know, and we went through this already. This is the first row, the second row, and the first column. So who can tell me what I need to multiply to get what's going to be in the second row and first column? So let me explain again. Maybe that will give you some time to insert. So when I was doing this, the first one, I said, hey, if I need what's going to be here in this entry, so remember, there's going to be four different entries. There's one here, and there's also one here. Let me give me some space. There's one here. There's also an entry here. So on the first one, which is in the position first row, first column, I take the first row of matrix A times the first column of matrix B. Now I'm here. I want to ask you, what do you think is going to be here? And if you don't answer it, I'm going to answer this one, and then I'm going to ask you that one. All right, cool. What do you think is going to be here? So what do I need to multiply to get what's going to be in this position? Let's see who got me. All right, cool. So to get what's going to be in this position, I need to multiply. So remember what position this is. Second row, first column. So I'm going to take the second row of the first matrix times the first column of the second matrix. And it doesn't get easier than that. Second row of the first matrix times the first column of the second matrix. And that's how you do it. You're going to do a dot product the same way. 5 times 4, -5 times -4, 0 times 0, plus 0 times 0. Now, let's go to the last one. And if you can think of this, whoever can think of what I need to multiply to get what's in this box, let me know. So let's go to this one. This one right here is what? What position is this? Second row, second column. In order for me to find what is going to be in the second row in the second column, I need to multiply whatever is in the second row for the first matrix times whatever is in the second column for the second matrix. And it doesn't get easier than that. Second row for the first matrix is this row right here times whatever is in the second column for the second matrix. Second row, second column. So second row, second column, this position means second row for the first matrix multiplied by second row, second column for the second matrix. Second row for the first matrix multiplied by the second column for the second matrix. So -5 times 2, -5 times 2 Think of this one. Let me know what I need to multiply to get to this. This is in the position, first row, second column. What do I need to multiply to get what if it's going to be inside of here? And then what? So -5 times 2, 0 times 1, plus 0 times 1. All right, so if you don't answer this one, I know it's probably, all right, let's see. All right, so I don't understand much of this just here because you seem like you're a good teacher. I don't understand. Thank you, I appreciate you. Aiden, Hanai, 69. Thank you, I appreciate the comment. Thank you. No problem. Yogurt, love it. So let's see. All right, cool. Thanks for sharing. Get my kids famous. Thanks for sharing. All right, cool. I'm confused again. All right, cool. All right, Jess, I'm gonna start over for you. Okay. Let's start over. And if anyone can think of what I need to multiply to get the x to get whatever is going to be here, this empty box, let me know. All right, let me explain. So matrix multiplication is a little bit different from addition. And multiplication, I said you have more leeway. So that means, they don't have to be the same row and the same column, just like when we're doing addition. So when I was starting out, I said, hey, if I have a 3 by 1, I can multiply by this by a 1 by 7. If I was doing addition, a 3 by 1, 3 rows and 1 column, by 1 times 7, 1 row, 7 column, you cannot add those with addition. But with multiplication, all I need to happen is the numbers in the middle need to line up. Need to be the same. So that 1 and this 1 is the same. I can erase these, and I'm going to end up with a matrix that's 3 times 7. That's it. Now, I think you understand that, Jess. So the second part that I'm saying is multiplication. When you're doing it, it's all about position. So what you want to do is, what do I need to multiply to get to this position? So now, this position right here, so before we start this, I have a 2 by 2 matrix times a 2 by 2 matrix. So 2 by 2 multiply by another 2 by 2. These numbers match. That means I can multiply them. So I erase these 2 in the middle. So that means the matrix I'm going to end up with is a 2 by 2. I think you told me that, Jess. All right, so now it's all about position. The positions that I need here is, that position is the first row. This one is the first row, and it's also the first column. So this position right here, it's the first row, first column, and that's the second column. So in order for me to find what if it's going to end up in the first row, first column, I'm going to multiply the first row of the first matrix times the first column of the second matrix. So notice that when I say first row, first column, first row of the first matrix times the first column of the second matrix. The first matrix is A. First row is this guy right here. First row. And what's the first column for matrix B is this. So I want something that's going to end up with first row, first column, first row of the first matrix, first column of the second matrix. Now, in order for you to do that, you got to know something called dot product. And it's nothing complicated. So what it is, if I have 1, 3 multiplied by -4, 2, these two things, if I'm multiplying them, I'll multiply this one by this one plus this one by this one. And that's exactly what I'm going to do. Multiply this one by this one plus multiply this one by this one. 1 times -4, 1 times -4, 3 times 0, 3 times 0. Just let me know if that makes sense. Now, moving on to the second entry right here. This entry is in the position of second row, first column. For me to find that one, I need the second row of the first. Notice I said second row, first column. Second row of the first matrix times the first column of the second matrix. Second row, what's position? Second row, first column. So that means second row of the first matrix times the first column of the second matrix. You're still going to do dot product. So what do you mean by dot product is multiply the first by the first, second by the second, the third by the third, however it is. So, and if you can't think of it because it's laying this way, think of it, okay, let me stand both of them up. Second row of this matrix is what? Is this. First column of the second matrix is these guys right here. So second row is -5, 0. First column is -4, 0. If you can't think of them like they were laying this way, think of them as when they're standing up. Multiply this guy by this guy. Add it to multiply this guy by this guy. -4 times -5 times -4. That means 20. 5 times 4 is 20. Negative times a negative is positive. 0 times 0, that means 0. 20 plus 0 is 20. And that's what I'm doing. Multiply top and top, bottom and bottom. So if it was laying down, just stand it up and then multiply top and top, bottom by bottom. And that should be it. Now, this position I said, and I still think about this position. If I see somebody enter this, I'm going to give you a big shout out. What do I need to multiply to get whatever it's going to be in the first row, second column? Now, let me go at the bottom one. I already did the bottom one. Let me show you what I did. So to do the bottom one, this position right here, I see it's the second row and it's also the second column. So that means I'm going to multiply the second row of the first matrix times the second column of the second matrix. Does that make sense? So what's the second row of the first matrix? This row right here. What's the second column of the second matrix? This column right here. So if you don't understand them because they're laying down, stand them up, stand both of them up. -5, which is technically not quite right. Send it like this so you can understand what the multiplication is going to be. So it's going to be -5 times the -2. I mean, -5 times 2 plus 0 times a 1. 0 times 1. And bam. -5 times 2, 0 times 1. Now, let me know what you think we're going to have to multiply to get to this one. All right, would row 1, column 2 be, all right, so somebody said 1 times 2. All right, so, all right, let's see. Jess, okay, let me see if I have any other questions before you. Let's see. In terms of Z problem, I don't understand your question. Who's asked the question? A_Swisham32. What's the website? All right, I'll type it here for you. TheJacksTutor.com. It's just my name.com. The name of that you see in here.com. So yeah. That's CLM. And then you'll see a blue link that says schedule a call, book an appointment, whatever it says, just click on it. I'll be able to book an appointment. So Z_orange juice, I just sent it to you. All right, cool. So let's see. Jess, you said row 1, column 2 be 1 times 2 plus 3 times 1. All right, so that means row 1. So that means row 1, no problem. So that means row 1. So this is going to be row 1, column 2. So row 1 of the first matrix times column 2 of the second matrix. Row 1 of the first matrix, 1 times 2, 3 times 1. That's right, yes. You got it. So 1 times 2, 1 times 2, and plus 3 times 1. Yeah. You got it. That's exactly what I would do. So now let's Let's see what this whole shebang gonna give us. This whole thing. All right, so let's do the top one. 1 times -4, that's -4. 3 times 0 is 0. That means -4 here. Let's go here. -4, -5 times -4 is 0 plus 0, 20. We already did this. And then let's go right here, the one that just found. 1 times 2, 2, plus 3 times 1, 3. 2 plus 3 is 5. -2 times 5, -5 times 2, -10, 0. -10. All right, so let's see. So we have -4, 5, 20, -10. And that is what we call matrix multiplication. And it gets more complicated if you have a 3 by 3 matrix or 4 by 4 matrix, and it gets wild. So basically, I kind of explained it to you guys, and the concept is the same either whatever matrix you're dealing with. Think about what position I need. I need this position. Okay, what is it? First row, first column. First row of the first matrix, first column of the second matrix. And you do the dot product. If you don't understand the dot product, the way it has one standing up, one laying down, just stand both of them up and multiply top and top, bottom and bottom. And you're done. Same thing for the other ones. So now, let's see. Okay, I'm going to do something called transpose of a matrix. And the transpose of a matrix, and then I'm going to do determinant, and then that'll be it for the night. I feel like we talk about matrix too much tonight. Okay, if you don't understand, let me know. If you already take algebra too, don't say you don't understand. And all right, that's fun. Thanks. Yeah, that was good. Thank you, Jess. Yeah, that was good. Hey, Gucci_Bob, what's up? Yeah, that was good. I just joined. I can't even see the problem. If you just joined, I think we're doing matrix multiplication. Gamer Boy 80. It's so nice that you're actually helping people. Thank you, Z_orange juice. Thank you. All right, cool. Thank you for your help. Angie1, no problem. All right, good. So let's do something called transpose. So let's start with this matrix that we have here. Let's do matrix A actually. Oh, all right. There's no more matrix left. So let's do transpose. So remember, when I say matrix, it's all about position. And then we can do determinant in a little bit. So let's do transpose. What was matrix A? Matrix A was, let's start with this. So the determinant don't get ugly. So transpose 1, 3, -5, 0. So that was matrix A. So the transpose of A, and they write this thing as A transpose. A T here means for transpose. So what it means is swapping the rows and the columns. And that's all you do. So you swap the rows and the columns and you find a transpose of A. So who can tell me now? I'll give you a few of the ones that we need to do, and then you'll tell me the rest. So swap the rows and the columns. So that means, so you're going to replace whatever. So let's say something was first row, second column. So let's say this thing that was in first row, second column. It's going to be in the second column, though, first row. So whatever was row for a number is going to become the column. Whatever was column is going to become the row. And it's nothing complicated. So what we're going to do is, so let's think about what we're going to end up with. Row 1, row 2, column 1 and column 2, column 1 and column 2. Now, okay, so this guy's in the first row, first column. It's going to stay the same, right? Because So what I said, I swap whatever was row, make it column. Whatever was column, make it row. But if you were in the first row, first column, when you swap them, you still get 1, 1, right? So what if it was 1, 2, it's going to be 2, 1. If it was 1, 3, it's going to be 3, 1. But if it was 1, 1, it still stays 1, 1, right? So that one is easy. That one stays 1, 1. So it's going to be first row, first column. That one stays. Same thing with the 0. 0 is in second row, second column. See, second row, second column. If I'm swapping 2, 2, I'm still going to get 2, 2, right? This 2 become a front, this 2 become a front. It doesn't really matter. You still get 2, 2. So this guy is second row, second column. It's still going to stay second row, second column. So that 0, 0 stays where it was at. Now, you can already tell what's coming. That means this guy and this guy are going to switch place. I'll tell you why. The 3 is in position first row, second column. Second column. First row, second column. Now, I'm swapping rows and columns. So this first rows, so the 1, it was 1, 2, is going to become a 2, 1. Second row, first column. Where is second row, first column? Second row, first column. This is here. So that means this 3 is going to be here. And then this 5, this negative 5, you know it's going to be here, right? But let me tell you what happened. Negative 5 right here was in a position what? Second row, first column. Negative 5 was in a position second row, 2, 1. Now it's going to be in a position 1, 2, which is first row, second column. First row. No, it was already 2. It was already 1, 2. Sorry. Second row, first column. Yeah, it's going to be in first row. Yes, second column. 1, 2. First row, row 1, negative 5. Second column. 1 column, 2 column. It's going to be right here. So, and that's what they call the transpose of A. And let me know if you understand. I'm going to give you an example, actually. And then before we're going to go into determinant. And that will do it for the night. All right. I'll give you an example. Let's take the matrix B, for example. B, I think B was, let me know if you understand too. If you don't, I'll show you another example. So let's take the matrix B. That was negative 4, 2, 0, 1, and that was the matrix B. So let's say that we want to know. So let's say we have this matrix here, negative 4, 2, 0, 1, and we want to know what's the transpose of B, which is B transpose. So who can tell me what the transpose of B is? Now, because it's matrix, I know it's probably going to be hard for you to answer. So I know these two is going to be the same. 1, 1, this is in position 1, 1, it's going to still be in position 1. When you swap the ones, it's still the same. 2, 2 is going to be still here in 2, 2. Now, what's going to be here? Tell me what's going to be here. In this position. In the position, first row, second column. What number is going to be there? All right, let's see. See if you can tell me what's going to be in first row, second column. What number is going to be there? Jess, you want to sleep? 0. Jess? Man, she is up. That's what's up. Yeah, 0. And then, of course, here is going to be 2. And that's it. Now, let's do something called determinant, and that will do it. That will do it for the night. I know you guys don't even have class and stuff. So let's do determinant of a matrix. So let's do the determinant of this matrix. All right, let me see if I can do the determinant of this. So The determinant of the matrix is you multiply this by this minus you multiply this by this, and it's not even something that's like complicated. So what do? You multiply -4 times 1 minus 2 times 0. Because 4 times 1 is -4. 2 times 0 is 0, and that gives you -4. Let's see. So who can tell me what the determinant is going to be for this matrix? Matrix A. All right, so what's the determinant for this matrix? Let's see. Matrix A is 1, and then that person is going to get the big shout out. I suspect it's going to be Jess. Let me get the big shout out, and that will be it for the night. -5, 0. All right, so you can tell me what the determinant of this matrix is, and that will do it for the night. Let's see, YouTube. Anybody? Opposite. Okay. All right. So let's see, YouTube. No one. Determinant. So all right, so let me make it easier. You multiply this by this, minus, so it's kind of cross multiply. Multiply this by this, 1 times 0, minus, multiply this by this, -5 times 3, and that's 15. Right? That's it. Yes. Okay. So it was 1, -5, 3, 0. And that would give you 15. Cool. 0, 15. All right. So let me see if you guys have any final questions before I call it a night. You got -14. That was for no, I think you're missing a 0. 15. Gucci Bob. That's what's up. 15. Cool. Yeah, that was it. Jess, you got close. All right. Yeah. All right, I'm glad you got it. Okay, guys. It's probably time to go to bed. Let me see if I got any questions. Who's still in school? I hope no one is. Which one of you guys still have class? Thank you, Sarah. No problem. Good night, Gucci Bob. Good night. All right. I'm glad you don't have class. Hopefully you guys did well in your last exam or your last class. Let me see YouTube. What you guys have going on? All right, guys. Everyone on YouTube, this what's up. All right, I think you guys are good. Okay, all right. So I'm done with online class on June 28th. Man, that's far away. What are you taking? Lab pork chop. School ends next week for me. What are you taking, Jess? G24. I've been done with school since May 28th. June 18th. Okay, that's a couple. No, I tutor privately. I'm not actually a teacher. Algebra 1. Okay. How's that going? Lamb, pork chop. How's that going? Yeah, Gucci Bob. I'm actually a private tutor, not tutor kids privately on my site, online, not on my site. Um, who else? Algebra one's going into honors, geometry. That's what's up. Nice. That's simple to me, honestly. Besides quadratic. When do you say your class ends? Let me see. I think you said on the 18th. Hey, I think we've done quadratic here multiple time actually. If you go on YouTube and go back to our videos, you'll see quadratic stuff. Um, yeah, June 18th. I think. Wait, what's today? The do we have another session before 18th? And radicals. Hey, lane pork chop. If you working on something, I don't know if we have a session before the 18th. If you're working on something and you have a problem with it, text it to me and I'll and then if we come back here again before your class ends, I don't know what's today. Today's the 9th. Yeah, we got another session before the 18th. You can text it to me. When's your next session and how do you get in it? My next section is next Tuesday. So every Tuesday around this time. So like 9 or 10 or 10:30. So usually I try to start around between 9:30 and 10:30. So but it's every Tuesday though. It's free. You just get in it. You go on TikTok, you'll see it live. You go on YouTube, you'll see it. Uh, I'm trying to get either iPod or something so I can go live on Instagram too. What times? I'm Eastern time. Yeah, Eastern time, New York time, Florida time. Yeah. So if you Lamb Pork Chop, if you have something that you're working on, text it to 904-299-8417. And then what I'll do is next time, you said you have problem with radicals and cosine. Oh, you in Central Time? Okay. If you have problem with radicals and that stuff, appreciate it. Tremor 12, Black Lives Matter, buddy. That's what's up. And if you have problem with radicals and stuff like that, let me if you working on something specifically, send it to me, and then next time we work on Tuesday, we'll work on it. It's 904-299-8417. Let me see what else you guys have. What subject do you hate? I wasn't really good in English. In any classes that requires like French or English, all that stuff, I really wasn't good in it. My English sucks, terrible. I'm not that good of a writer. I'll be able to speak. I prefer like video and stuff like that. I'll be able to speak, but I'm not really that good of a writer. Social studies, the worst subject. That could be bad, especially if you have to write stuff in it too. Think now you have to think about it and then write stuff. Mm. I don't know. For some reason, I kind of like. I took and that's probably not even close to social studies. I took a sociology class. I kind of liked it, uh, and I don't know why, but it was cool. Not that I liked writing the papers, but it was cool the concept. That they were talking about in there. I have ACT Saturday, and I practice on subjects? Where's that? Or where's that? Now, Savannah, I would say for me, it depends. Like this is gonna require like the answer is probably not gonna be. I don't want to give you an answer that doesn't fit whatever you have going on. But I'd say right now, if I was taking the ACT, what I would do is between now and Saturday is do a bunch of take the exam a bunch of time. So actually sit down and take it. Don't worry about it. Now, the other thing is absolutely cannot do math if that helps. Now, if you have little time and you know you won't be able to do well in math. So what I would do is, focus on the stuff that you are good at, because it's you have what, 5 days. So there's no way between now, if you don't know anything about math at all, there's no way between now and Saturday you're gonna be ready. Now, if you have stuff that you're really good at, because what they look at is the composite score, you know, but they sometimes they put some emphasis on, if you do like if you had a 2 out of 36 for math, they might put emphasis on that and say, all right, two, you need to raise that up. But what they really look at is composite scores. And I think, if I'm not mistaken, some schools they take your higher score in each subject. So let's say your highest score in English when you take it in October, and it was like a 31, and your highest score in math in February was 22. So they kind of take consideration of those. So I would focus on the stuff that I'm really good at right now. And because you only have 5 days, if you had 5 months, that would have been quite a different answer. Um, and so that way you have a higher composite score. Because if you focus on math right now, there's probably a little bit of stuff that you're going to be able to do between now and then. Whereas if you're good in English and you just need to, strengthen a couple points so you can get a 36, that would have been better to focus on English, if that makes any sense at all. I'm doing algebra 2 and still don't know what to do. Are you finishing up, or you taking this next semester? I saw Mar underscore 3. Are you taking this next semester, or are you just finishing up? Yeah, no problem. Trig seems hard. It can be. If you catch the class in the middle of of everything, it can be hard. But it's kind of like with any math class, they build upon previous subjects. So if you understand like little things about triangles and sine and cosine, when they talking about those, if you understand uh, the basics, usually you can build upon that to kind of get it. And then with all of those two is practice. If you don't do them, I mean, like you wouldn't believe in myself if I don't do anything with math for a long time. When you get back to it, you're like, all right, snap, I forgot how you used to do this. Especially if you don't do it on for a while. Let's see. Let me see what you guys are wearing again. How's their whole course on just triangles? How is their whole course? I know, right? Um, I know, same thing I'm saying. But you'll be fine if you understand the basics. But part of it is just practice too. That's the most part of it, because you can understand anything that I'm doing here, but when you try to do it on yourself, you're like, what did he do again? You will help me in math this year. No problem, Sydney at Wood 18. So I'll tell you guys what I'm working on right now before I go. So currently I'm working on 6 different courses, and so what those will be is like the hardest math class in high school. Is those all? There's gonna be what are they? Algebra 1 and honors. So like each one of those includes the honor class. So algebra 1, algebra 2, geometry, trigonometry, pre-calculus, calculus. So what I'll do in those courses is step by step explanation of little concept. Each one of those. So let's say I'm working on algebra 1 and I want to show you how to solve equation. So I start with stuff that are really, really simple. 2x equal to 4. So you know how to do that. Now I add to it 2x minus 5 is equal to 4. Now I add 2x. 2x minus 5 is equal to 4 minus x. Now you see how it builds upon this. So I'm working on those courses. So what's going to happen is whenever whenever you go to those courses, I'm trying to see the best way to deliver this to you guys. Whenever you go to them, so what's going to happen is you'll be able to step by step follow a bunch of instructions that eventually will lead you to be able to understand each subject really, really, really well. And then in the middle of it too, there's going to be stuff for you to practice. And when you're not able to answer those questions, what's going to happen? You're going to be able to go to a video that helps you with the practice. So if you're not able to, if you stuck, you're like, oh snap, I don't remember how to do this equation. You answer the question and it says, okay, this is wrong. Click this video to watch how to do it better. I as you know, you guys know I have a bunch of videos to YouTube and all over the place. So those videos are the ones you're gonna be able to see me explaining it. And then I'll explain it in a way that makes sense. I don't like to use like jargon and big language and stuff like that. I like to use languages that you guys use, and that's why you're able to understand me too, because it's not about using big words. It's things that you can relate to, and that's why you're able to understand me. I think I saw a question. Oh man, I'm sorry to hear that. What makes you think that you just failed? Nick, Nick, Nick. It says Nicola's future wife. What makes you think that you just failed the class? The next live is next Tuesday, so we come every Tuesday. So I come here every Tuesday to help you guys. So the next live is next Tuesday. And then the course that I was talking about too. So what's gonna happen is I'll do. So like when you take the course, you'll get more lives, and also you'll get like a Zoom conference meeting. So you'll be able to see the stuff on Zoom. It'll be cool. So conic section. She just ran and say conic section. What about them BHAVYARORA? I think math is better to learn in person, so it was hard online. Okay. I can see that. Yes, math is hard to get online. Okay. You teacher is like school. I don't know if that makes sense. No, I'm not a teacher. I tutor kids privately, and I do that online. It's normally 1-on-1. Most of the time, it's 1-on-1. So, kids go to my site and they schedule a time, and I work with them online 1-on-1. So I don't actually go to a school and teach. I don't know. I was never interested in that. I don't know why. But I like to sit down 1-on-1 with kids and tutor them. What's 8 times 7? I think I'll get back to you when I get the answer. I literally wasn't paying attention in class when I talked about condensation and a graph. Are you taking things that talk about conic section now, or are you? I don't know. Is your class? What I'm saying is your class still going on, or do you have classes? You have to take tests on it, because we could probably do something next Tuesday. If you're working on something specific, we could probably work on something next Tuesday to help you understand it. Yes, it's like an intro to conic section. We just learning about it. Okay. If you have thank you, Maddie 08. If you have stuff that you're working on, let me. You could probably text it to us. Text it to me, and then next Tuesday I'll come and work on it. If not, now if you text it to me, there's a good chance that next Tuesday that's gonna be the first thing that we work on. If not, if I remember, I'll just put it on my calendar, and I'll just put it on my calendar to talk about it. So what I'll do is just just put it as part of the stuff that I'll be talking about. Who's your favorite teacher when you were young? Man, I had um I had a few teachers that I kind of liked, and I don't know, for some reason I could relate to them, and and they were pretty interesting too, different personalities. I had a biology teacher that I liked, and he I don't know, he was like short, and when he comes to class, he's like, uh, I think he must have been like a botanist or something like that. He just comes to class with like a pen and something to write on the board, and he was just good. And I really wasn't really good at. I can't remember anything about biology, but I think I liked them too. I had a bunch of course, most of my math teachers I liked them. Um, there was one teacher that I spent from like I had from like sixth grade to like 12th grade. He was always my math teacher. For like it could be I don't know. He was teaching a lot of math classes at the school that I was at the time. Uh, his name was Jumel, and he was good. He was really good, and I remember him being really like patient. And when he was explaining stuff, you could sit down and learn. And him too. Like I remember, he never really bring books to school. He just sit down and explain stuff to you. I had another professor that was an engineer that I really liked him too, and he was a civil engineer, and he was good too. In college, I remember this one guy. What's his name? Thomas Betty. Yo, this man, when he comes to class, first of all, the reason why most of the kids in my class liked him, when you take math with him, he could give you a homework that has 10 questions. And out of those 10 questions, he picked one of them to grade. And if you solve that one problem, you get 10 out of 10. So that means you get an A for solving one problem. So, but the trick is you gotta solve the one that he's gonna choose. He chooses one of them to grade. He doesn't grade all of them. So he said, okay, today I'm gonna go. After he gives you the homework, he might say like, okay, for this homework, I'm grading number 3. If you solve number 3 and couldn't get the other one, you still get a 10 out of 10. And he was cool too. When he comes to class, he comes like empty-handed. I don't know. I can relate to stuff like that when teacher comes and he's not reading out a book. He's just telling you stuff personally that he knows, and you can follow him a lot better that way. And I kind of like him. I remember him telling now because he was really good. He was really good. So I have a few of them that I really liked. Um, yeah. Let's see. Thank you, Alex underscore 21B. I've always done it. Sammy was here. I've always done tutoring. I think it started maybe when I was like in ninth grade. I started really becoming like really interested in math, and then of course I'd get higher grades, and then the kids in my class, they weren't really into it. So they would ask me, "Hey, you want to stay after class? We're gonna work. We can work." And then we just worked. We just did it, and I showed him how, to the best I can understand it. And then it went from that to ninth grade, 10, 11, 12. Like when we graduated and stuff like that, they had we had at the school that I was at the time, you had exams that you had to take, like official exams, kind of like similar to SAT that you had to take to get out of high school. And so we would work the whole time before we take the exams, and they would go on and pass. Uh, and they work with me like every afternoon, mostly every afternoon. There's close like from Monday to Friday, we always work. So after class, we go home. We live close by. Go home, eat, come back to the school, and then just work on math. So I'd be tutoring them, and then eventually that went on to me when I started college. I think my second semester, I started tutoring. Believe it or not, I was tutoring chemistry, and because I took chemistry and I did not did well. So that's the only thing I could tutor at that time, and I think calculus too. But mostly kids weren't really interested in calculus. There was not a lot of kids taking the calculus at that time who were in the program that I was tutoring at the school. So I would get a lot of kids taking chemistry and mostly statistics. That was most of my clientele, most of the kids that I tutored. And then that went on to no, I don't play video games. I play with my son, but he's too good. We play what is called what's this game that nobody could find recently? It's not what is it? It has Mario in it. What is it? Nintendo Switch. So I play with him, and he is good. Like he'll kick my butt every day. Like I play with him. So yeah, so yeah. After that, when I went to college, I was doing it. I worked for the school for like 2 years, and I was doing tutoring math, and then eventually I ended up doing it on my own as my own gig instead of going to instead of doing it for like a instead of working for a company. I thought I would just do it myself and have more flexibility. Let's see. Yentenko, Yatenko. Hey man, I passed maths because of you. Thank you. I appreciate you. Congrats, man. Actually, congrats. Hey y'all, give it up for Yatenko, man. Help me say congrats to Yatenko. His name is Yatikle. Hey, my man, congrats. Good stuff. I'm glad you were able to pass. And yes, that's what's up. Thank you, Jarek Bidama. Man, I can't read your name. Thank you for saying congrats to my man Yatanko. Thanks, man. Congrats again. Good stuff. I hope to see you next time. Bailey, thanks for the gifts. Thank you again for the gift, for the PIMDA, Bailey. Thank you. Jess, thank you for saying congrats to my man Yatanko. Same thing, Sammy was here. Thank you. Animal Crossing. Yeah, man. Video games it's never been my thing, but my son is like, I don't know, he's really into that Mario stuff. And we've been playing, and he is good. This man could be playing for like 2 hours. Do you recommend Khan Academy? Yes, it is good. When I was in school, when I was in college, every time I had a class I couldn't understand, I'd go in it. Khan Academy is really good. It is. Now, it depends on how much you like math. so Sal, the guy who created Khan Academy, actually he really goes deep into theory with you in terms of like teaching you things, the way that like he goes a lot of in terms of going a lot of theories and a lot of he gives you a lot of background about what he's talking about, what makes it really good too. If you really enjoy it and you can follow, it's gonna be a good resource, and it's always a good resource. And I think that's probably one of the best out there to be that's free also. So I like it at all. I like it a lot actually. Now if you have difficulty to follow, you want somebody to just give you the answer. I don't think he's that guy. But yeah, he's really good. He's really good, and that's a good resource. I don't know why people are not using it as much, but I found it very helpful when I was in college. I used to use it a lot, almost daily, because some of these classes they were tough, and when I go there, he would have it on there, and I just go and sit. I think I was taking calculus 3, and I was using it. Calculus 3. I think I use it for differential equations, a bunch of other classes that he has on there, and he has, he probably have way more stuff. I mean, a lot more stuff than anybody out there in math. Um, that's also free. So yeah, it's kind of hard to beat Saab. Yeah, he's good. That's all my school use, but they overuse it, and now I hate it. Yeah, that's what I said. A lot of it is like it has theories in it. So sometimes if you're not, if you don't have a whole lot of math background in math, sometimes it may not, it may not be the same, best resource for you. Like I said, when you able to say things in a way that kids understand, when I was explaining matrices here, so the way I was saying it to you guys, it wasn't, I wasn't using like the math jargon, like um, things that you like you would only understand if you didn't have a lot of background in math. Some of you guys never take algebra 2, but you were able to understand what I'm saying, and I think that might be a difference, in terms of explaining things in a way that that most people can relate to. And if you're not really into math, you might think that it's probably too much. But yeah, he's good. He's good. Yes, I only do math. I used to do other stuff like chemistry, physics. I can do statistics too, statistics and math, which is kind of like math. So, but I'd stick to what I know now. I wouldn't try to do chemistry anymore. Um, Good, Sammy. Nice, nice. That's what's up. Yeah, and then when you actually taking the class, it will be like a piece of cake for you because you already know. Like if somebody start talking about matrix, even if you didn't get the whole thing that we're saying here, you will know exactly what it is. You will know exactly how to add them, and it will just be a review for you. So you'll be ahead of kids in your class. Let's see. What do you recommend for SAT prep? Um, so I always tell you guys it depends how you learn. So if you learn, yeah, you're gonna have to go through the math part to do well. Uh, so yeah, if you learn through like videos, the best thing to do is find places that has videos. I have a bunch of those on my YouTube channel. Khan Academy is a great resource too. They have a bunch of them free, and mine is free as well. So there's probably other channels on YouTube that has a bunch of them. So if you're into videos, if you're into like reading stuff and learning about them, now you might have to go to the library and pick up a book for free and learn that way. Um, Now, the best thing I would say is any exam that you're preparing for is practice. So if you don't do that, there's no way you're gonna pass. So if you don't practice, you'll know the stuff, but like you won't be able to do them in the amount of time necessary for you to do well in the exam. So it'll be hard for you to pass. I don't want to say there's no way, but it'll be hard. You'll be facing a lot of challenge. So what I would do myself, if I wanted to learn right now, I would go find, kind of like a book that has a bunch of exercise in it. But to actually learn this material, I'd probably go like on videos. So either anyone that has a few, videos online for free that you can trust and you can understand, because people can have videos about SAT, but if you don't understand what they're saying or what they're trying to teach you, it's going to be hard for you to do well. So if you can relate more to Khan Academy, just use them. If you can relate to the stuff that I have too on my YouTube channels, just use it too. Or if you want to do a combination of both, that's fine. So the best thing is, all right, which one of, because teachers are different. You can say your teacher sucks, and then Mary think he is the best teacher of all time. So if you can relate to what the person is talking about, just use that person and then use them to understand the material. But also you have to do it by yourself. If you don't, it's not gonna work out the way that you think. So I would say either read or watch videos about it and then just do them. Once I have more stuff for you guys, I'll let you know. Let's see. All right. I think I need to go to bed now. Yo, y'all, it was good. It was good hanging out with all of you on YouTube and TikTok. I don't know what's going on with the YouTube. It's awful. All right, cool. It was nice hanging out with you guys, and I look forward to seeing y'all next Tuesday. Thank you very much. If you have any, I prefer the way you teach. It's easier to me to understand than my own math teacher. Thanks, Sammy was here. Thank you. Yeah, good night, Gucci Bob. See you guys on Tuesday. Good night, all of you. And if you have any questions or anything that you're working on, you can always text them to 904-299-8417. And good night, Sammy. Good night, everyone. And I look forward to talking to you guys next Tuesday and posting some more stuff on my channels too. All right. Thank you guys. Bye.